So now in this video, we're going to look at the 7805 voltage regulator. And so the 78 is the series of integrated circuit. The 05 is the voltage, 5 volts. So we input higher than 5 volts and it outputs 5 volts. And it does a really good job. It's actually a really cool component. There's a lot to learn about it, but we're just going to go over some simple stuff in this video. So there you can see L, and that's probably the manufacturer, 7805, and then CV. So there's probably slight differences from the base model, but it should work exactly the same. Usually, I think always, they're improvements of some kind. But in any case, to wire this up, we're going to take the input pin and the ground pin. Input is going to go to that jumper that goes to the positive rail, and ground, we can zoom in a little bit. The ground pin is going to go to the negative rail. Also, this tab here is like connecting directly to that middle pin ground. So the tab is also ground right there. And these pins are quite a bit bigger than the wire leads of other components and stuff. So they're kind of stretching the board. This is probably my most damaged area, so I'm going to use it for these odd components as much as possible. Now we will grab my mini oscilloscope, and we can see that we have it wired up like this. We're going to have higher than 5 volts coming to the input. Also, it's a good idea to have capacitors to help stabilize things, but we're not going to need it for this video, so I'm not going to add them. But I wanted to make sure to put those capacitors there just to make it clear. If you got voltage fluctuations, you may need some capacitors. So we have the output pin down at the bottom there, and of course it's going to return to ground. So we got the power supply coming to ground, the negative rail, and then our load's going to end up going to ground, the negative rail right there. But first, we're going to take a look at the voltage. And I put the light there because it's a little better for seeing the components, but it makes glare on the meters and stuff. So I'm just going to take the black alligator clip here, put that to the negative rail with a jumper. Oh, also, you can put a heat sink on there. So I bought these heat sinks a while ago for these TO220, 220, however they refer to them, packages that look like this, and you just screw it on, and there's a little insulation here. So I think this does it helps transfer the heat, but I also think that it prevents, if you touch this, from it connecting to ground. I think it isolates the two, but you do have the screw there, so never mind, forget I said that. There is paint on there though, so maybe that helps. But in any case, main takeaway is, there you can see we got 5 volts, went up 5, and the rail, probably 7, yeah, 7 right there. The multimeter here, you can see 7, and we're using up about 3 milliamps of current just powering this thing, and I bumped something, so we got some noise there. Again, that might be why you would want a capacitor, but we don't really need that for this. So now we can raise this up to 35 volts, but this unit only goes up to 30. So I'll just jump up to 30, and there you can see we got more current, and that went up. That's not good. That voltage went up. So in this case, 30 volts was too high. So that's a good thing to know. There we go, 20 volts. We got 5. So I'll have to look into that a little bit more. Now, there you can see it's holding 5 volts as we go through all this. Looking right there. I'll turn the light down. That should help show the display. There we go. I went to 3, and you can see it's about a volt less. So really, you want to be about 2 volts. I mean, above the one you're using. So we're still like 4 something. And so at 6 volts it went up, but it's still good to keep it about 7. Otherwise, you lose some voltage. And so now what we're going to do is we have 5 volts at the output. I'm going to take an LED right there, protected with 220 ohms. That's really about the minimum value. I should have used one without a switch there, but in any case, we'll power this directly. That's about the minimum value you want to use for 5 volts. So if we get above 5 volts, we'll have problems. So as we just saw, we don't want to exceed 20 volts. And I will move the LED here. So short lead the cathode to that jumper, long lead the anode, up 1 row right there. And these do get really hot. We're not passing hardly any current now, so but don't touch it if it is passing quite a bit of current. And we should see the LED light up. There we go. So it's lighting up with 5 volts. The resistor is to the output right there. And I made a loose connection or something. We lost some power for a little bit. But in any case, there we go. We will back up. We can still see the voltage. So that's across the resistor and the LED. It's at the output. And so we got about 20 milliamps total. So that's the unit and the LED. We had like 3 or 4 milliamps with just the LED. And I'm not going to go much above 20. There we go, 21. And it's still holding. So at that current, it looks like it's holding the voltage better. Right there. We're still 5 volts. So that was a good test. Without the load, it was going up in voltage after we did 20 volts. So in any case, really straightforward, just 3 pins. You basically power it with a higher voltage than the number where the X's are, so it's a 78 series. So there's a 12 and a 12 volt and a number of other voltages. Plus there's a negative voltage, and I think those are the 79 series. I don't have any of those. But otherwise, it's pretty straightforward. You just got 3 pins. If you need stabilization, you can add capacitors, but as you can see there, for this particular circuit, it worked just fine without them. They shut off automatically when they start getting too hot. And so I didn't find a wattage rating. The only wattage I found on the data sheet, I always consult the data sheets, don't go by what I say, but it said internally restricted or something, I can't remember. Basically it was saying that if it starts getting too hot, it automatically starts protecting itself. It limits current or whatever it does, shuts off or whatnot. So in any case, read up more on them. Other than that, that's it for this video. Higher voltage in than the rated for the particular component, and you still get the rated value out. It is equal, the voltage out. Pretty straightforward. So thanks for watching. I'll see ya in the next video.